What I'm about to show you here is the city of Hamilton, Ontario, Canada, overlaid on the map, the blue lines. Is the track of a specialized transit bus as it travels through the city on any particular day. The city of Hamilton is made up of a number of boroughs, and this bus system represents one of 80 buses. You can see here that on the west end of the city, we're at McMaster University. The buses have made several trips into the facility. Similarly, farther west in Dundas, again, the bus has made several trips into the city. And as the map backs away from the city, you can see that the blue line draws a pretty random drawing. Now, through the use of GPS devices, DARTS has been able to collect geographic locations, longitude and latitudes of all the pickup and drop locations. Now, here you see that we have the data collected in a table. The first item is the date of the particular incident, the estimated time of arrival at the pickup and drop off. We have the run number of the particular bus, the activity at the geographic location, whether it's a pickup or drop off, and of course, the all-important longitude and latitude, which is the absolute location of the pickup and the drop-off. Now we're using this data to plot the individual run on an XY graph. This is where the mathematics comes into play, because with the use of tools, we expect that the University of Waterloo's Combinatorics and Optimization group can help us with the optimizing of the runs. Here you see that we have the city laid out as Flamborough at the top, the mountain of Hamilton is at the bottom, Ancaster to the west, and Stony Creek to the east. And the city center, which is St. Joseph's Hospital, is at the zero origin of the graph. This particular graph starts downtown, this particular bus run, and ends in Stony Creek. You can see that it also makes a trip out to past Flamborough to Burlington, but also doubles back on itself quite a bit. So with a graphical representation like this, you can see there's an opportunity to use mathematics to improve the scheduling of buses. Here, this particular run starts in Stony Creek and ends downtown. It makes a number of trips out to Ancaster, which ends up doubling back on itself, as you can see in this particular curve. The amount of time that the bus is spent empty, which is called deadheading, and the amount of time that the bus spends with very few passengers is of concern to the service. This particular run, 721, shows starts and ends in Stony Creek, but does make a number of trips out into the Ancaster region with very few dots, which indicate a pickup or drop-off. So what this particular project will attempt to do is to use mathematical models to determine what makes a good schedule and to support our initiatives to identify ways and means of enhancing the service, specialized transit service scheduling.